Hello, my name is Xander and welcome back to FastAPI. In the previous tutorial, we created a very simple FastAPI implementation with GraphQL. In this tutorial, we take it a step further and implement token-based user authentication. So don't worry if you haven't seen the previous tutorial, we're going to draw down that code and start from that base. If you're interested, there is a link in the description. We created a FastAPI implementation with GraphQL, SQLAlchemy, Postgres database, and here we're working with Docker Compose to build these services in containers, and we're essentially working from Docker containers. So if you don't have Docker Compose or Docker desktop installed, then go ahead, you're going to need that to install that in order to follow this tutorial. So just a quick breakdown before we start then. This tutorial, we're going to implement a simple token-based authentication system. So first of all, we go through the process of building a new user model, and then we'll create some mutations so that we can actually add users or new users to the system. Once we've done that, we go through simple authentication. So we'll set the system up so that we can authenticate a user, and then we'll migrate that or we'll move that forward into token-based authentication. The final step here will be to actually implement it into our system so that when a user logs in, they can then perform certain actions that someone who couldn't log in can perform. So here we have a post creation option. So here we're building a blog API. That's the example that we've started. So what we're going to do here is we're going to restrict it so that only logged in users can actually create new posts. So to give you a preview of what we're going to end up with, here we have GraphQL where we can simulate some of the different queries that we want to serve from our API. So here we have a mutation. This is for a new user. So what we'll be able to do with the system at the end of this tutorial is to create new users. So here we just have username and password, username test20, password test20, and then let's go ahead and run that. So you can see that we've created a new user. We return OK, true. So now we've added a new user, we can now go ahead and actually log in. So we have username test20, password test20. So what's going to happen here is that when we log in, we're going to provide that user a token. There we go. So we provided that user a token. So this token uniquely identifies this user. And so if we were to send this token over to the API, it would mean essentially that this user is logged in. So therefore, this user can now perform actions as someone who's logged in. So let's use this code now to perform an action that is only allowed for those people who are actually logged into the system. Okay, so here we have the mutation, which is going to create a new post. So here we have a setup where we're creating some posts for a blog, for example. So this could be absolutely anything you want it to be. So here what we're going to do is we're going to create a new post, title and content. So let's give it a title and content. And what we're doing now is we're going to use that token that was provided to us when we logged in to pass it over to the API. And that's going to authenticate this user as someone who's logged in. So when we go ahead now and run this, you can see that we've added a new post. So that data here has been now saved to the database. A new post is now being created. So we should be able to capture it. So imagine we change this token slightly. So this token should now not match someone who's logged in. So if we try this, you can see here we have invalid credentials, meaning this token isn't valid. So therefore this user cannot actually create a new post. So only those who are actually logged in and have a valid token will be able to perform actions of a user who's logged in. Right, okay, so hopefully that's given you an insight into what we're going to develop here in this tutorial. So let's go ahead now and build from our example. So go ahead and use the link in the description, download the code for this tutorial. We're going to set that up. So I will take you through that process, and then we'll start by creating a new user model and then create the user mutation so we can add new users. So first up then, link in the description, go ahead and download the code. This is what we're looking at here once you've downloaded. So this is the previous tutorial. So you notice that we're using Docker Compose and Docker files. So you are going to need Docker installed for this. If you haven't already done that, please go ahead and do that. So we will be running from a virtual environment as well. So just skip ahead. We'll just quickly create a new virtual environment. And then we'll go ahead and install the requirements for this. Oh. It's like I've not done this 100 times. Hundreds of times. All right, so now we've activated the virtual environment. So let's go ahead and pip install the requirements file. So that's just going to install all the requirements, of course. So first of all then, let's make our way over to the models file. Now I'm going to go ahead and create a new table. I've already done it. So you can see here I've created the user table with 3 fields. So we have the ID, unique field, primary key, index true. And here we have the username, which is also going to be unique. So here we want to authenticate via the user's name. So we don't want there to be 2 users with the same name in the system. So unique is true is also on the username. So in addition to that, we have the password. Now you just need to make sure that there's enough room to store the password, because here what we're going to do with the password, and we're not saving it in clear text, we're going to encode it. So we just need to make sure that that encoded string will be able to actually fit inside of our field. So if we left this blank, it wouldn't be a problem at all. I'm just making that point. If you do have, or if you have set a limitation on the actual field, just make sure it's a long enough to actually store the new data. Right, so with that in place, we now have the new table. So now we need to build a mutation. So essentially we need a way of actually entering data into our database through our API. So we're going to make a mutation. So that's going to essentially handle taking that data that's going to be passed in and then actually storing that in our database. So in our main file here, at the top, it doesn't matter where we put it. Essentially, I've just put it here just below the app FastAPI. So here what we're going to do is create a new class called create new user. So this is going to be a graphing mutation. So we're going to create a mutation here. That is just a word essentially for post, if you like. So we're going to send data to our API. So now we're going to set up our arguments. So essentially these arguments are the data that we're going to try and pass in and handle to save in our database. So here we have the username, and that's going to be a string. Now here I set this to required true. So in order for someone actually to create a user, there must be a username. So I've set that to explicitly required true. So unless there is a username provided, then we're not going to move forward. So same thing again with the password. It's going to be a string that's going to be passed in, and then required true is also applied to the password. Obviously, without a password, we can't set up a new user. So next up, we're also going to just return something. So this is just going to be OK. So when we create a new user, we're just going to set OK to true. So this is a Boolean here, and that's just going to confirm we've added a new user to the database. Right, so now we move on and create our static method here. So we pass in the requirements. So here we're going to pass in essentially username and password. So we're expecting the username and password to be passed into this function so that we can perform some actions. Of course, that's going to be saving this data to the database. So next up, we're going to take in the password that the users typed in, say, to a form and passed across to our API, and we're going to hash it. So we're going to make it secure in our database. So we don't want to store in clear text the password. We want to hash that password so that we create a random set of numbers and letters, for example, so that anyone who maybe hacks into our database, they can't see the data. So this is essentially a one-way process, hashing. So it is slightly different from encoding. So it's well worth understanding the differences between encoding and hashing if you don't already know. So what we're going to do here is we're going to use bcrypt. So this is going to be a library, a set of tools that is going to help us perform some of these actions here. So what we're going to need to do is install this. So let's go ahead and do that. So pip install. So once that's done, we're going to just need to bring that in. So let's import bcrypt at the top here. Okay, so that's imported in. So let me just go ahead and do a bit of that and just make sure that our settings are in place. Apologies. 1 second. Okay, so we import the bcrypt in. So that's now nicely imported in. So we're going to use the #pw hash password function from bcrypt. So you can definitely go ahead to their website and just type that in and learn a little bit more about that. But this function essentially takes in 2 items. That's the actual password that we're passing in. Now we are encoding that to UTF-8. And then in addition to that, to add some additional security, we're also going to use a salt, which is essentially kind of a random string that's going to be generated and used in order to add security to this hashing process. So a uniqueness, if you like. So now we've created we've taken the password, we hashed the password, add some security to the password. We're now going to move ahead. Now I've left this link here because that's going to be pretty useful to understand what's happening next. So what's happening here is that this hashed password isn't going to be inserted into our Postgres database correctly, because through the process, the original process, it's likely to get encoded again. So through the process of saving it into a Postgres database. So this link here is going to provide you a description of what's essentially happening here. So what we're going to do is run this piece of code here, basically just to make sure that that process doesn't take place, so that the actual hash gets stored in the database and not kind of a encoded version of the hash. So we just need to make sure essentially, and like I said, this link will kind of give you an understanding what's happening here. This is just an additional process. We're using Postgres database. We just need to make sure that this data is handled correctly through the process of saving it to the database. So we're just going to go ahead and use hash password decode. So we're going to take this hash here, password. We're just going to prepare it correctly to be stored in the database. Right, so with that done, we can now move ahead. Right, so user equals user schema. So we've got some data. Now we're going to pass this by our schema to make sure that the data that's passed in is the data that we're expecting to store in the database. So here we're going to create a user schema. Right, so let's go ahead and go into our schemas here. And we're going to now make a new schema for our user. So I'll just paste this in, or not. So we're going to make a new class called user schema. And we're just going to have 2 items here. That's going to be the user and password. They're both strings. So that just confirms the data expected to be stored in the database. So that's going to be connected to our user schema. So we're going to bring our user schema in. So at the moment, we do have a post model and post schema. So let's go ahead and bring in our user schema so we can access it here. So we've now kind of prepped this data ready for us now to think about storing it in the database. So let's now go ahead and do exactly that. So dbuser equals models.user. So here we're bringing in the user table. So it looks like we're going to import that from models. Yep, that's okay. So let's just double check that. So from models, we're now going to import the user table. And what we're going to do here is we're basically going to take user dot username. So we passed the username by the schema. Now we're going to get the username out from the user and the password hash. And now that's going to be saved to the database. So essentially what we have here is the actual query that we're going to run. We're going to find the user model, or the user table, sorry, and then we're going to save the username and password. That's what's happening there. So we can add that. So db add and then the db user. So we're going to add that to the database. And now we can go ahead and try to actually commit this. So what's happening here then is if we were to add a new user here without kind of following this pattern here, if we were just to go ahead now and commit this after we added, so we'll do a db commit, db refresh, that would save it to the database. That would be absolutely fine. But what would happen here, to try and explain this, so just to make sure we're all on the same page here. So we've created a query to add a user and password. We then go ahead and add that user ready to the database. And then we use, for example, here we could run db commit here, and that would then commit that to the database. Right, so that would save absolutely okay. But the problem is here we're using a session. So if we were to add a new user to the database again, if we were to try to do that, what would happen is that we would receive an error, because essentially, to try and explain this, we're still using the same session. So we kind of just need to kind of refresh the data now we want to go ahead and store this new user to the database. So in order to handle that correctly, I've left this link here to transaction has been rolled back due to previous exception during flush or similar. So this just kind of spells out what's happening here, and through SQLAlchemy how to kind of manage that. So here we're going to use a try except, so db commit. So this is where we're going to actually try and commit this new information, and then we're going to refresh, and then I'm going to pass OK equals true. So that's what we're going to pass back to the user. That means that the user has been saved to the database successfully, and then we can move on, return, create new user, OK. So that returns the data back to the user. So obviously, if we do have a problem, we're going to run db rollback. So this is going to explain what's happening here in more detail. So definitely go ahead and read that. And then you can raise an error if you want to. I'll leave that for you. And then we'll just close. So this is just going to assure essentially that if we wanted to save 2 users, we could do that. Right, so with that now in place, we now have our function in place to actually capture data that's been passed over to the API, and now ready it by creating a password hash and then storing that in the database. Right, so now we have this new mutation. We need to kind of register this new mutation so we can actually use it. So down here we have our create post, and then here we've defined all of our mutations. Right, so let's go ahead and create new user. So let's call this create new user. Okay, equals create new user. So this should be a field. Okay, we're not using a list here. So field, and there we go. So now then, when we run our front end, we should be able to pick this up, this new mutation. So what's important here is that because we've installed a new package, new library, we're going to need to do pip freeze, and then just update the requirements, because when we run our Docker setup, it's going to take this requirements file and then obviously load that up in our container. So we just need to make sure that we're also loading up the bcrypt toolset so we can actually use it for our hashed password. Right, so that shouldn't be a problem now. So let's go ahead now and just make sure that Docker's ready. So you can see that I have a previous implementation here. So I'm just going to go and close that. I'll just close all this down. So if you have anything here from maybe the previous tutorial, let's just get rid of all this. So that's going to slowly close down. See if I can speed this up a little bit. There we go. So I do have a volume. So we are images. We are using Postgres and pgadmin still. So let me just remove that. So that's just going to leave these images here. That's absolutely fine. So let's go ahead now and Docker compose. So there shouldn't be anything that we need to add to the Docker compose file. So Docker compose and up. We could do a build first, but let's just do up. So that should take a couple of seconds. So we're just going to build the new app image, and then we're just going to start up. So it looks like everything started okay. So now let's just go ahead to our browser. Okay, so this is just a previous task here. Now I could use history. Here I've got this already set up. So here we're going to create a new mutation. Right, so let me just refresh. Right, so here you can see that we've got the mutation new user. So this is a query that we're going to run from the front end. Apologies. So here essentially we're kind of simulating the front end. Maybe you're using a React app to kind of communicate with the API or Vue or something like that. So here we're going to create this here, new user. And then what we want to do is create a new user Username is going to be test1, password test1, and we want to return OK. So that should return true or false based upon whether the user has logged in or not. So let's press execute. And here we go. So it looks like we've got a problem here. Insert into. So the problem we've got here is that we need to now migrate, because we've started Docker, we don't actually have any tables. So we're going to need to migrate that all over. So what you shouldn't have is anything here in the versions. So you've got this file here called text. Now I put this here simply because we've got an empty folder, and using GitHub, that folder wouldn't exist. So I've just put this file here. So what we're going to need to do, if you're not familiar with this, we have our models. We need to actually put these models, we need to actually get these models inserted into our database. So let's go ahead and open up a new command prompt. Make sure that you're in a virtual environment. Now, all the commands here are in commands. So first of all, we need to make a migration, prepare our models, be ready to be inserted into the database. So that should successfully run. And now we can go ahead and commit. So we're running this command actually on the app container. So this is going to run the commit. So now what's actually happened is that we've now made new tables in our Postgres database. So I appreciate this is kind of behind the scenes. I'm kind of assuming you saw the previous tutorial. So let's go back here. We can now see that when we run this, we're returning true, and we've actually entered someone into a database. So let's go ahead and log in for those who haven't seen this. So this is the admin for pgadmin. So this is the container that we've set up for pgadmin.com. So that's going to log us in. The password's admin. So now let's just quickly add a new server so we can access our database server and see the data we've just typed in. So the username is Postgres. The password is going to be password. Press save. This is all described in the Docker Compose file. So we've got our database. This is our database, PostDB. Let's go to schemas. Let's go to tables. And inside of tables, we've got a new table called user. And then if we go to view or rows, we should have a new user called test1. And you can now see that we have this hashed password. Now, if, for example, we didn't go through that process, if we go back into main here, if we didn't add this here, what we would see is a different password, which would start with a slash. So if you're receiving that, it's because you've not used this correctly. So your hashed password should ideally start with a $sign, but it definitely shouldn't start, with a hash, with a slash, for example. Okay, so actually we might as well just show you. So let's just remove this line 27 on main. So I'll just save that. And remember, here we are mirroring across from our container. So we are, when we're working with these files now, we're actually working with the files in the container. So this is our app container that's currently, our app container here, which is currently running. Just close these down. So we're working within this app container. Right, so let's go ahead now and just create a new user again. So I'll create a new user test2. Obviously it needs to be unique, otherwise it won't work correctly. So I've created a new user. Name password hash is not defined because I've not updated the code properly. Apologies. So let's just put this into the passwords. This is just for an example so you can see what happens. So let's save. So we saved a new user. Let's go back here and refresh our data. And you can now see that this second item has a forward slash. So you can see the difference here. This is a correct hash. This is not correct. So that's why we actioned this piece of code here. And like I said, there's a description here of what that is with the invalid salt. Okay, right. So now we've done that, we've successfully created a new mutation so we can actually allow users to create a user account. So now we have the ability to actually create counts. We now need to think about actually authenticating the user. So logging in the user. So let's go ahead now and create a new mutation here. So we're in the main file again. I'm just going to put it above the create new user mutation. So let's go ahead and create a new class called authenticated user or whatever you like. So this is another graphing mutation. And we now just need to find the data we want to work with. So username and password. So we'll be expecting a username and password. So we're going to do this first of all without the token, and then we'll go ahead and implement the token afterwards. So we have the username and password, and we're going to use the OK again, Boolean. So just to confirm that the action has taken place. So here we're going to return if the user has logged in, true, and if the user hasn't logged in, false. So next up then, let's create our static method. We're going to bring in username and password. So if you're not too sure what root and info is, just go ahead to Graphene or GraphQL and do a little bit of reading there. So this is just really the bringing in all the elements that are required or maybe needed into this mutation. So let's go ahead now and create our user. So we're going to be utilizing the user schema, and we want to just validate the username and password. That's what's being passed in. So the user schema we've already brought in. We've already created that user schema, so it's expecting username and password. All right, so now we have, where were we? So now we have that in place. We just need to now define how we're going to actually insert, or sorry, first of all, we need to check. So what we're going to do first is we're going to take the username. Okay, so if the username exists, we're going to do something. So let's just now grab that username. So db user info. So we're going to create a new query on the database. So the model is the user model, and we're going to create a filter. So models user username equals username. So we're just going to grab one of those items, or the first item that returns. So this is just a query on the user table, a filter. So we're going to look for the username in the table, in the user table, where the user equals the user name that was passed in. So obviously, if we do have a user, that's all good, because we can now go ahead and create an if statement. So we probably just need to do something there. So we probably needed to do something there, but you get the general idea. We're going to change this shortly when we move over to the token, but that's the idea. That gives you an idea. We're going to grab the user. Right, so okay, so now we're going to do something with the password. We want to check the password. So we're going to use bcrypt again, check password. So this is a function, a bcrypt function you can go and read about, check pw. So what it's expecting here is the password. That's the user password that's been entered in, and then the password that's from the database. So just, okay, I see what I'm doing now. So we've got the object back. So this here gets the user object back, returns the user object, sorry. And now we're going to use that here, the dir user info, to grab the password that's returned from that object, which should be, if the user has typed in the right information, the user object. Okay, so that's the user that's returned from the database. We're going to use it here to check the user's password that they've entered, and then the actual user's password that's in the database. Apologies if that doesn't, if that wasn't clear. I kind of tripped up there a little bit. Right, so now we've got that information. So if we do return true here, we're going to set OK to true, and then we're going to return authenticated user OK true. So that just basically means now the user has logged in successfully. We check the username and password against the database. Else, we're going to set OK to false, and we're just going to return that so we haven't logged in, there was an error. So that's pretty much it for that. So we just need to now go and register this mutation. So this is authenticate user. So at the bottom here, where we entered the previous, create new user, I've just put it up the top here, authenticate user. So I've added that in. So now we can go ahead and try and authenticate the user. So back in GraphQL, so what we're going to do now is run this mutation. So authenticate user, and we're going to pass in the username password. Essentially here, what we're doing is, if you imagine this is the front end, this would be the login form. The user would type in their username and password. We know there is a user test1 and test1 in the database, so that should work okay, and we return OK true. So if we were just to mix this up a little bit, obviously this doesn't exist, so it's a wrong password. You can see that we get false, or else if we type in the wrong username, we also get an error, which we should really go ahead and capture a little bit more effectively. But you get the idea. We now have a way of authenticating the user. So what we're going to do next now is once we authenticate the user, we want to return a token, and that token is going to then be used every time the user requests something that is protected or we protected with a login system on our API. Okay, so now we have an authentication system in place. Let's just go ahead and we're just going to remove this code here. So now what we're going to do is we're going to implement authentication so that we can supply or provide a user with a token that they can then use to authenticate themselves in our API or to get data from our API as an authenticated user. Right, so first of all then we're going to need to install. So we're going to be utilizing JWT. So let's just make sure we install the correct one. So there's a few different packages here. We're looking for PyJWT. So don't install JWT here. So this is pip install PyJWT. Okay, so that's the package that we're going to be utilizing. Now, because we have done that, it does mean that we're going to need to restart. Oh, well, let's just do it anyway. We'll just do it this way. It's just clean. So we'll just remove our containers and our image. We'll just rebuild our image, and that will then include the new package. So let's just pip freeze requirements. That will just update the requirements with what we've just installed. We should have PyJWT. Yep. Okay. So that's going to be the package that's going to allow us to kind of generate tokens. We're going to utilize that to generate tokens. Right, so let's go ahead now and just double check. I don't think we're going to need anything else at this point. So let's go ahead and just Docker compose. Let's just bring everything back up again. Right, so we will be passing back to the user a token. So let's go ahead now and just add that in here. So that's going to be a string. Okay, so let's go ahead again. Exactly the same thing again. The user schema is going to be the username and password. Okay, so we now have that, and we go ahead again and we query the database and find the user object that's associated with the username that's been typed in. So we go ahead and do that. And then same thing again, we create this if here. So we go ahead and just check the password. So if the password does match, then we go ahead and we will then create a token. Right, so tokens will expire, so we can define how long tokens exist. So the idea here is that the token that we generate will have a timestamp and within it. So that means that when the API kind of checks the token, that if the user is authenticated, it's going to read the time. Now, if the time runs out, that means that we need to get a new token. So it's kind of like a security mechanism here, in that we issue tokens and they kind of run out. And that provides obviously a certain amount of security. Otherwise, that token will be potentially available to use forever. And that's never a good thing, because that could be potentially, be generated or found out by a potential hacker who maybe is kind of generating keys and just trying out different keys to log in. So we set the time frame, and then we go ahead now and access token. We're going to create a new function, create access token. So we're going to pass into that function the username and also then the expiry date. So access token expires. Right, so time delta. So let's bring in time date. Okay. So that brings that in. So that leaves us now with creating this new function. So we're going to build a new page for this, a new file. So let's just call this JWT token, for example. Okay, so let's go ahead. Now we're going to import OS, because what we're going to do is we're going to generate a random key that we're going to be utilized to help the encryption process, if you like. So we're going to put that in the environment file. That's going to be like a secret key. So let's go ahead and do that first. Actually, so we're going to create a new option here. It's going to be called secret key. So as long as this is over, say, 35 values, then that should be absolutely fine. It's just something random generated. So that's going to be a secret key. All right, so let's go back into here. So we import OS so that then we're going to set that up in a second. So from datetime, let's import datetime and time delta. We import JWT to generate the tokens. And then from .env, load .env. So if you remember if you were here in the previous tutorial, what we've done here is we've created some environment variables that we're going to be utilizing for security reasons that won't be able to be accessed on the server. So we're using .env, which is going to, in our local machine here, basically just load this up so we can access these environment variables. So from .env, that's the package we got installed, we're going to load .env. So that's then going to allow us to actually kind of load the environment files here, and then we can utilize it for our secret key. So here we access our secret key in our environment file. Right, so on a production server, you'll kind of key all that in, and that'll be behind the scenes. That won't be accessible only by the software. So that's in. And now we define what algorithm we want to use. So it's worth reading through PyJWT to work out what algorithms you can use. Obviously, there's a plethora of different algorithms. So for no particular reason, HS256. Right, so let's create our function. I'll create access token. So we pass in the date and the expiry delta. So if we go back here, you can see here the data, user username and expiry delta. So that's the kind of expiry time. So we've set it at 60 minutes. Okay, so now what we're going to do to encode, so we select what we want to encode, we set the expiry time, and then we update encode with the expiry time, and then we go ahead and essentially just encode it all. So this then generates our token. So we pass in to encode the data we want to encode, secret key. So that's going to make this obviously unique. And then algorithm equals algorithm. That's the algorithm we've selected. Right, so that's going to create our token. So we want to return our access token. So let's go back now into main. So we're calling create access token. So we're going to need to bring that in up the top here. So from JWT token, import create access token. Okay, so now we have our token. Right, so that should be pretty much all we need to do at this point. Sorry, no, of course not. We need to finish this off here. So we are going to OK true, set OK to true, because at this point we've got our token. Everything is we've checked the password, and we've got our token. So let's return the token, access token, and just the fact that we are logged in. Right, so once we've done that, if that doesn't work, of course, we're just going to return OK is false. So yeah, now we have that in place, we should be able to test this and actually now return our token. We don't need to update our mutation at the bottom because we've already done that previously. So we should still have the mutation at the bottom there. So we just need to remember this time to define that the fact we want to return the token. So back in GraphQL, assuming you've got everything started, so just double check everything is working okay. Yep. And now we want to return OK and the token. Right, so we do this and we've got a problem. Object has no attribute password. So let's not forget we did add a new package. So we're going to need to recreate the table. So just go ahead in the commands if you've forgotten. Here we're going to make our migration. Now, this is where you need to remember potentially that if you've already got an existing migration, you may need to delete that first before you move on. So let's just go ahead and recreate our table. So that migrates the tables from models over to the database. So now we just need to go ahead again. So again, if you're not too sure, this is a new user. So first of all, we need to run this new user mutation. So let's create a new user, test1 and test1. So now we can go back and we'll try and authenticate the user. So this time, okay, and token, let's run this, and there we go. So now we've returned our token for this user. So now we can go ahead and think about securing something. So in the previous tutorial, what we did at the bottom here, we had a way of creating a new post. So here we created a new post. This is a mutation, title and content, and then we just returned OK if something was entered into the database. So this was just a way of creating a new post. So obviously what we don't want is what we have now, as anyone can make a new post. So what we want to try and create here is that only authenticated users can perform this action of actually creating a new post. All right, so let's go ahead. I've just removed some of the code from create new post, the existing graphing mutation that we had in our code. So we're going to take in title, content, and token. So we're going to need to add token now. And then we're going to get a result, which I've called result. And that's just going to be a string. So we're just going to return result, which is going to return to the user, or just return the fact that it was successful, or that we've returned a post or not returned a post, and so on. So that just gives us a little bit of feedback. So let's build our static method again. So this time root info title content and token this time. Okay, and then we're going to try. So we're going to try to payload equals decode access token. So we're going to try and take the token that's being sent across, and we're going to try and decode it. Okay, so we're going to grab the username from that payload. Okay, so the username should be kind of embedded in that token that gets decoded. So now what we're going to do is we're going to take that user from our token that we've kind of decoded from our token, so the user, and then we're going to check. We're basically going to check to make sure that there is an actual user that's been kind of generated from that token. So this is just a kind of if statement. We're going to raise an error if a user isn't found within that payload. So next up, if there is an error in general, we're going to raise invalid credentials. So if we enter the wrong token, for example, we're just going to raise another error here, which I've called invalid credentials too. So we're just going to test this out, and you're going to see where these different errors arise. So next up then, we are then now going to run a query. So on the users table, filter models, user equals username. So we've got the username here. So we're now going to utilize that to return the object, the user's object from the database. And then we're now going to check to make sure there is a user. So if we don't return a user, then we're going to raise an error. Okay, so if the user's typed in the wrong username, for example, let's just doubly check to make sure that we're going to raise an error. Right, so now then, if we get through that, so essentially what we've done here is we've checked the token, we've checked the user, that they exist, etc. So if they do match the database, if there is an entry in the database, we're now going to go ahead and allow them to post their data. So this is just the same as what we had before. We'll take the title and content, run it against the post schema in the schemas. So it's expecting title and content. If you want to expand that, don't forget to include the information here in the schemas, and don't forget to also include the fact you want to kind of work with this data. So we need to add any extra fields here you want to include or add to your model. Okay, and then obviously here as well. So there's a few sections that you just need to follow if you want to kind of expand this to other fields. All right, so now we've got that in place. Let's add it to the database. Let's commit it, refresh, and then we're going to say the result is added new post. That's what we're going to return to the user. And there we go. So we just return it back. So this should now only allow those who actually logged in or have a valid token to be able to actually add new posts. So let's test this. All right, so what we're going to need to do here is log a user in, and we're going to need to grab the token. So what you can do here is already pre-prepared the mutation here. So let's go ahead and just add the new token in, and then we go ahead and utilize this. I run this mutation. So this is a create post, and we're going to send in a title and content and our token. Okay, that's the important part. So we've got our token in here. Apologies. Just have a look at the syntax here if you're not too sure. So let's go ahead and create a new post. So it looks like we have an error, and that is because we've not brought in all the tools. I've just forgotten. I do apologize. So let's go back to main. So here, the GraphQL error, and we utilize something else as well. I can't see off the top of my head, but let's just bring in that at the top of our file here. So we're going to need to bring in from the GraphQL error, and in addition to that, the PyJWT error as well. I think we're utilizing that. Here we go. Okay. Right, so let's go back into our code. Let's run this again. So it says name decode access token is not defined, because again, I've not finished this off. So let's just follow this through. So what we need to do now is, apologize for this, we need to decode. I've forgotten about this. So we need to, our payload obviously needs decoding. So let's bring in that. We need to build it, of course. So we'll utilize the JWT token page. So this is a function we're going to build now in this file here. So we've got the create access token. So let's just go ahead now and create a decode. So we're going to decode the access token. So what's going to happen is we're going to pass in the data, and then we're going to use JWT decode, and that's expecting data, the secret key, which is obviously coming from our environment file, and the algorithm. Now notice here one thing is that algorithm is used for the JWT encode function, but algorithms with an S is JWT decode. I'm not entirely sure. Well, okay, so you just need to remember that's the case. That catches a lot of people. So with that in place, we now have our decode. We have decoding, so we're going to decode our token and then just return the data and then access it. Right, so now we've got that in place. Let's go back and give this a go again. And there we go. So we've now added a new post with our valid token and all the details we need to add a new post to our database. So if we change the token, let's give this a go. You can see here we've got invalid token, or sorry, invalid credential 2. So the only reason I've numbered them here is just so that you can then easily see what error is being produced and whereabouts, if I move it down, apologies, whereabouts it is in the code. So here we're trying our payload to decode. Obviously that's not going to work. So yeah, we're basically just raising an error here. The fact that we've got an invalid token. Right, so if we were to think about some of the other rules, here's just a case of thinking about what other things we need to think about. So here, for example, we've got invalid credentials 1. So what happens if, for example, the user deletes their account and then they try and log in? So let's just go into, it's a bit of a pain, I do apologize. I'm just going to go into, PGAdmin. You can see that I'm following the football right this second. This is dedication for you. We're going to go into the final of Euro 2020. And the first time in, I don't know how many years, 50 years, I'm making a tutorial. Right, so this is admin. Okay, so let's just add this to a server. So we're just going to show you, if I delete the user and try and log in again as that user, we shouldn't be able to log in, so we need to capture that. So this is just connecting again to my database. So this should be password. Okay, so in my database, there's another thing to learn here in actual fact. If you want to go to your schemas, your tables, if you want to manage your data from here, for example, we can edit directly. So let's just change test1. Okay, so we're just pretending that's a new user now. And then I need to press F6 and that will save the data. So F6 here will save the data. I've never actually learned which item I need to use to save, but I just know F6 saves. Right, so now we've saved that there. Let's go back in. Let's just try this again. Now this is the same, not the same token, is it? So let's just use our old token. And this time I get invalid credentials 3. So that's because I've changed the username. So if user equals none, then I get invalid credentials 3. So here I'm just raising the error when, for example, the user is incorrect, but you notice that the token is okay. So there we go. So there's just some things to think about. We now have a way of kind of validating the user against an activity, utilizing the token. Of course, any other activity now you want a person who's logged in to perform, obviously there's going to be the same type of process here. We're going to need to validate their token. Now, thinking about the front end here, you're probably asking, well, how do I actually implement this on the front end? So obviously these queries would be run by front end React or other kind of front end technologies that you want to utilize to access your API. We would be sending this type of query across. And then another question is, well, where do I store my token? So let's just say, for example, you would store this token on the front end package and you would utilize that to send off requests. Okay, so that's just hopefully I mentioned and hopefully you're aware, that's a simple token-based authentication system. Hopefully that was useful. It gives you a little bit of an insight how to start thinking about utilizing tokens. A lot of this is obviously, if you're using Django or other types of frameworks like Django, this is potentially all behind the scenes. You don't necessarily get to see this kind of close up. We can download packages and we can automate this process very easily. And so hopefully it gives you a better insight of potentially what's happening or how token-based authentication works. But here, of course, in FastAPI with GraphQL. So I do hope that was useful. Thank you very much if you got to the end there. I always appreciate it. Obviously not many people get right to the end. I appreciate that. So if you have got this far, thank you very much for watching the whole way through, and I hope to see you in the next tutorial.